All right, today we're going to be doing operations with radical review. So we're first talk about how to simplify square roots or radicals, and we're looking at how to do all the operations, addition, subtraction, multiplication, and division. So first off, we have things called perfect squares. That's when you take a number and you multiply it by itself. I always write my perfect squares with under the radical because that's what we're looking for in the end. So the list of perfect squares are the square root of 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and the list goes on and on and on here. I usually write out just the first 10 there. You're not going to use the square root of 1 very often. It's usually start from 4 up to 100. The most often are the ones you're going to see. So first, we're going to look at how to actually simplify a radical or a square root. From here on out, I do expect that if you see a radical as an answer, that you try to reduce it. So when you're doing this, you're going to be referring back to this list up here. So looking at 48, so how I do it is, if you don't know the factors of 48 off the top of your head, look at the highest number first. So the highest number that could go into 48 is potentially 36. 36 doesn't go into 48. 25 doesn't go into 48 evenly. 16 does go into 48. 16 goes into 48 3 times. So I would break this apart until radical 16 times radical 3. Oops. I know that the square root of 16 is actually 4. The square root of 3 I cannot simplify because it's not up on my list. So the answer here would just be 4 radical 3. And that would be my answer there. For example 2, we're going to be subtracting here. So one big thing I want you to know, when we're doing this, in order to subtract or even to add, they must have quote-unquote like radicals. Okay, so this problem is currently like doing 4x minus y. All right, so we have the 4 times the radical 12 minus the radical 27. The radical 12 and 27 aren't like radicals. All right, so just keep this in mind. This little thought bubble here. Okay, in order that they must have like radicals. All right, so our goal is to have the same radical. So what we're going to do here first is we are going to simplify these. All right, so I'm going to look at the 4 radical 12 and that minus 27. We're going to kind of break those down. So first off, we've got that 4 radical 12. All right, so I'm looking at 12. I look up the list of perfect squares. I know that radical 4 goes into 12. It goes into 12 3 times. So I've got 4 times radical 4 times radical 3. I know the square root of 4 is 2. 4 times 2 is 8. Radical 3. All right, 27 here. Look at my list of perfect squares, 27. I know that 9 is a factor of 27. It goes into it 3 times. I know the square root of 9 is 3. So now I have the problem 8 radical 3 minus 3 radical 3. Now you have to know that this is like saying 8x minus 3x because those radicals are the same. So when I look at this, I'm going to do 8 minus 3. Well, 8 minus 3 is 5. And I have those radicals there because they're like terms are like radicals. So my answer is 5 radical 3. Example 3, we're going to be multiplying now. We've got 3 radical 6 times 5 radical 3. We have something that we need to remember here. All right, this is like this. Radical A times radical B, they're not the same numbers under those radicals, is like doing this. Radical A times B, you can actually multiply those numbers and get a new number there. So this is kind of like 3x times 5y there, where that x is at radical 6 and the y is at radical 3. When we do this, we can multiply the like terms at 3 and 5 and get 15 and combine the x and y into 5xy. So that's exactly what we're going to be doing here. If I rewrite this problem, I've got 3 radical 6 times 5 radical 3. What I'm going to do first is I'm going to be multiplying the numbers on the outside there. 3 times 5. 3 times 5. Then I'm going to be taking the radicals, radical 6 and radical 3, and multiplying those together because they're like terms. 3 times 5. Well, 3 times 5 is 15. Radical 6 times radical 3 is radical 18. Now you need to pause and see if you can break down radical 18. Well, I know the square root of 9 goes into 18 twice, so I would say this is 15 times radical 9 times radical 2. Square root of 9 is 3, so I have 15 times 3 times radical 2. 15 times 3 is 45 radical 2. All right, up next we have a combination of operations. We're doing multiplication and addition and subtraction here. With this problem here, we've got in the first parenthesis 3 radical 2 plus radical 3 times in the second parenthesis radical 6 minus 4. What we're going to do here is we're going to FOIL. All right, so the first one here is 3 radical 2 times radical 6. 3 radical 2 times radical 6. We're also going to do 3 radical 2 times negative 4 plus 3 radical 2 times negative 4. Where we're going to then take that second term, radical 3 times radical 6, and radical 3 times negative 4. From here, we need to do some actual work. So the first off thing, we have 3 radical 2 times radical 6. All right, so I can combine that into 3 radical 12. Over here, I've got 3 radical 2 times negative 4. So that'd be negative 12 radical 2. Over here, I've got the radical 3 and the radical 6. Radical 3 times radical 6 is radical 18. And then over here, I have radical 3 and then negative 4. Those aren't like terms, so that would just be negative 4 times radical 3. Now, as of right now, none of my radicals are currently the same. I've got radical 12, 2, 18, and 3. So as of right now, I cannot add or subtract any of those. We need to go through and see if we can simplify any of these. So I know radical 12 can be broken down. I know I can break radical 12 down into radical 4 times radical 3. I know that radical 4 becomes 2, so I've got 3 times 2 times radical 3, which would just become 6 radical 3. I know that radical 2 cannot be simplified, so that's going to stay the same. I know radical 18 can be simplified. I can break that down to radical 9 and radical 2. I know radical 9 becomes 3, radical 2, so I've got plus 3 radical 2. And I know radical 3 cannot be reduced anymore, so that stays negative 4 radical 3. From here, I have some that are like terms. I have 6 radical 3 minus 4 radical 3. So that's when we can look at those outside numbers. 6 minus 4 is 2 radical 3. And then I've got negative 12 radical 2 plus 3 radical 2. So I can look at those outside numbers. Negative 12 plus 3 is negative 9 radical 2. And that would be my final solution because those are not like radicals, so those would be your final answers. All right, example 5 here is going to start the division. So we've got 12 divided by radical 3. This is what we call rationalizing the denominator. And why we call this rational in the denominator? When you have a radical that is in the denominator, it's like nails on a chalkboard to us. We don't like it. So we need to get rid of that radical in the bottom somehow. So what I'm going to do is I'm going to rewrite this problem quick. I've got 12 divided by radical 3. How we do this is we're going to multiply actually by that denominator, radical 3. And we're going to multiply it by top and bottom. So I'm going to say radical 3 over radical 3. This is what we call a form of 1. Okay, because radical 3 divided by radical 3 would just be a form of 1. All right, so it's not really changing our problem here. If I do this, I'll multiply the top together. So 12 times radical 3 would just be 12 radical 3. Radical 3 times radical 3 would be radical 9. I know that radical 9 becomes 3. So I've got 12 radical 3 divided by 3. And then we look at these outside numbers here, that 12 and 3. 12 divided by 3 is 4 radical 3. One common misconception I see people do is they'll try to do radical 3 divided by 3. The issue is radical 3 is under a square root and that bottom 3 is not. They're not like terms, so you can't do any operations with them. They have to be like terms in order for you to do those operations. All right, another example here. Example 6 has radical 3 divided by radical 6 plus 1. So very similar to this last problem where we have a radical in the bottom, but the issue with this one is that we actually have a radical and an operation of that minus 1 occurring as well. So what do you guys want to rewrite this problem here? What we're going to do here is we're going to actually multiply it by radical 6 plus 1. So it's that denominator, but the only difference is that I changed the sign in between. All right, this is what we call the conjugate. Okay, it's the conjugate form of 1 where you change that sign. So if I start this problem here on the top, I'm going to have to do radical 3 times radical 6 and radical 3 times 1. On the bottom, I'm also going to FOIL all that out. So I'm going to do radical 6 times radical 6 plus radical 6 times 1 plus negative 1 times radical 6 plus negative 1 times 1. Oof, that's a lot there. We're going to do some simplifying here. Radical 3 times radical 6 is radical 18. Radical 3 times 1 is radical 3. Radical 6 times radical 6, which is radical 36, which actually simplifies down to 6. Radical 6 times 1 is radical 6. Negative 1 times radical 6 is negative radical 6. And negative 1 times 1 is negative 1. If I look right here, I've got the negative, or radical 6 times radical 6 minus radical 6, so this would cancel each other out. So I've got 6 plus negative 1, which is just 5. I'm going to look at the radical, see if there's anything else I can simplify down. I think, and I know that I can simplify radical 18. All right, that would break up into radical 9 times radical 2. I know the square root of 9 is 3. So I've got 3 radical 2 plus radical 3 divided by 5 as my final solution. What I want you to do, I want you to pause this video and I want you to try these two on your own. All right, I'm going to put my answers up here, but try these on your own to see how you do. This would become radical 5 divided by radical 8. I can simplify this down. That bottom will actually become 2 radical 2. I can multiply both top and bottom by that radical of 2. I've got radical 10 over 2 times 2, which is just radical 10 over 4. I'm going to multiply the conjugate here, which is 1 minus radical 2. On the top, that will simplify to 1 minus 2 radical 2 plus 2. On the bottom, that's going to simplify down to negative 1. So now I've got 3 minus 2 radical 2 divided by negative 1, which is actually just negative 3 plus 2 radical 2.